The first step in getting inside the unit involves turning it around so you can access the back panel. There are a number of Phillips head screws on the back panel. They need to be removed. And because I do this all the time, I use a powered screwdriver, but a regular Phillips head screwdriver will also do the trick. This unit happens to be a 2014 unit. When it was built, the Q150 standard series was in production from 2010 to 2018. In 2018, the Plus series came into existence, which essentially the only difference between the two is they redesigned the case and they put a different display system in there, which actually is a large enhancement on operability as well as ease of programming and updating the software. Once you get the back panel off, while you're back here, it's helpful if you start disconnecting at least 3 cables. One, this is the high voltage cable that goes from the sputtering power supply, which is mounted over here, to this cable up to the sputter head. The next one is one that's not really often used. It is an internet cable. It allows us to program your display or update your software via the internet. It also allows us, depending on what your company or institution's IT policy is I can remote in with my laptop and update the software as well as troubleshoot any issues you have. This rarely occurs because most companies will not allow you through their firewall. The most important cable to disconnect is the interconnect between the display cable and the power supply, which is a D-shaped or D-sub connector. I believe there's 9 pins there, and it just unscrews. Just lay it on the power supply for now. Now we need to turn the instrument around to remove the cover. Once you have the unit facing forward again, raise the arm and temporarily remove the glass cylinder. And you'll need a number 3 Allen key. You need to remove the shoulder screw, which locks the support arm in place. Once that's loosened, you can rotate the machine again 90 degrees. There's 2 large Phillips head screws at the base of each side, and they also need to be removed. Once you have the back panel off, the side screws removed, the shoulder screw removed from here, the display cable's disconnected, you can next remove the actual cover. Now, some caution needs to be taken because the cooling fan right here is plugged into a board up towards the front of the chamber. So we gently lift it up and forward at the same time. And you don't want to pull on the cable which attaches to this board right here. So once it's unplugged, the entire cover can be removed. This connector right here is where the fan plugs in. It's got a little latch on it, so you need to squeeze it and just pull it straight up and off. First thing you need to do is to unplug two cables from the front of the power supply. This 5-pin connector. It's keyed, it's got a lip on it, so when you put it back, the lip locks on this white tab back here. You need to remove the display interconnect cable and just set it aside. Next, you need to remove this rather large plug from the front of the unit, and it's got a latch on it, and I use a large Phillips screwdriver to depress the latch. I gently tug and pull it up. Try not to pull the wires out of the connector. That's a rather unfortunate problem. This cable goes to the cooling fan, so you can leave that in place. The next thing you'll do is there's two screws on the base pan here. You can't see them right now, but there's two Phillips head screws there. So we use the long-handled screwdriver to undo them. Now, essentially the power supply is free with the exception of the evaporation cables, which I'll show you how to detach. These systems come configured in 3 different modalities. You can have a system that will only evaporate carbon, or it will only sputter with no evaporation source, or as it is in this case, the combined evaporation and sputter source. So since this is the combined with evaporation and sputtering, we have to remove this cover to undo these very large heavy copper cables which supply power to the evaporation head. So to do that, we'll just move this sputter high voltage cable out of the way, and we're going to remove a series of screws on the cover with a smaller screwdriver. There's 4 Phillips screws which hold the cover to the evaporation supply in place. So once those are removed, you can remove the cover, exposing those very large heavy-duty copper cables. So what we're talking about are these 2 big heavy-duty cables. I don't know if you can see it from this view, but one cable has a red marking on it. That goes on the inside connection tab. The one with no marking goes on the outside connection tab. This is the high current output to the sputter head. This is the return, and this is the device that measures the actual current applied to the carbon thread or carbon rod when you evaporate it. This allows the power supply to control the amount of current precisely, giving you a relatively consistent evaporation. So these are big heavy-duty screws, so we'll use the larger screwdriver. Break those free. The wires can be removed temporarily along with their grommets and strain relief. And now the whole power supply can be removed from the unit. Now, as I said, this is essentially goes into electronic waste. Some materials are recycled, other materials are discarded in the electronic waste. So we'll just set this over in the recycling area for now. Now it's time to essentially reverse the process and install the replacement power supply. I have a new power supply here on the bench. I already removed the cover exposing the evaporation power supply, because the first thing we have to do is reconnect the evaporation cables to the sources. So the first thing we'll do is lift it and set it into the system. You'll note that the only difference is that there's a dust filter on the inlet of the fan. Other than that, it's the same power supply that was in there, essentially the same design. It's just the filter keeps the debris from evaporation and sputtering from falling inside the instrument, and since sputtered material, in this case they're sputtering gold, as well as carbon flake from the carbon evaporation process, if it gets inside the case, which it does, it can be sucked into the electronics, and those are conductive materials, and previously have been implicated in the shorting out of some electrical components. That's why they put a filter on it now. So the first thing we'll do is we'll identify the cables. This is the one without the red mark, so that will be mounted on the outside. Now the red evaporation cable, which I explained previously, is the return circuit for measuring the actual current that you're applying across your carbon source. Okay, once that's in place, we can reinstall this cover. Okay, so while we're back here, we're going to make sure that the mains power module fits in the slot where it's supposed to. The output for the rotary pump is in its slot. This is the fuse for the rotary pump. That's its sole purpose, is in case of the rotary pump drawing more current, than anticipated, this fuse will blow. It has nothing to do with the other parts of the power supply, only the rotary pump. There are no user serviceable fuses on the inside of the power supply. There's only very dangerous high voltage and high current. This is why I won't even go inside while it's powered. So what makes sense to do is to re-anchor the power supply to the case. Okay, and once you have those 3 screws in place, it makes sense to plug the high voltage cable back in, so you don't forget to do that later on in the reassembly process. Now you can spin the unit back around so it's facing you. And what we'll do is we'll reinstall these 2 screws that are at the front base plate of the power supply. Next we'll start reattaching the plugs. The big plug only goes there. This has got a lip on it which goes to the back. We'll toss this over top, even though it's really not used anymore. We will plug in the display connect cable, which is really just the same plug that you would find on an internet cable. And now we're ready to test the system. All right, everything's connected up. What I've done is, since I don't like to put the cover on until I test it to make sure everything is okay, I use my laboratory test display, which is easier to connect than to remove the customer's display from the cover of the instrument. It just saves a little bit of time. If you're doing this in your own lab, you can just drop the cover back in place, but since we're here in my lab, I will do it this way. First thing you do is, of course, once everything is all plugged in and it's connected to the rotary pump the way it would normally be, I did clean the sealing surface, the L gaskets, the sealing surface of the chamber, as well as the sealing surface up on the top side, just to make sure there's no vacuum leaks. Turn the power on. Now, as you can hear, we have fans running. The display is showing its correct configuration. First thing we'll do is we'll run the stage profile. As you can hear and see, the stage that I mounted is rotating, so that's all being controlled correctly. I've put a glass cover slip on the stage just to see what the coating looks like when I'm done. Now I'll close the lid. One of the common things people forget to do is to check the O-ring seal, which is underneath the insert here, and make sure it's free of debris, as well as the surface around the insert is clean to prevent any vacuum leaks. Lock the 2 halves of the head together. And let's see, gold 5 nanometer profile is already pre-programmed into this. I will edit the profile a little bit. Hold, yes, okay. Okay, that's all good. Alright, so now we're ready to test it. So we're going to run the profile. The chamber is under vacuum right now. So we'll come back once this pumps a little bit. Since the system was an atmosphere for quite some time and the chamber is quite dirty, I allowed it to pump for a little while. Right now the vacuum's at 2 to the minus 2 millibar, which is approximately as good as it gets with a rotary pump system, depending on the length of the pumping line and how well you maintain the system in the vacuum chamber. We'll hit continue and terminate the pump hold, and we'll see if it sputters. So right now the argon gas is bleeding back into the system to the correct sputter pressure. It's controlled by this little valve here, very precise valve. It's also quite sensitive. It only works on 4 to 6 psi. If you have it much higher than 10, it will actually create a leak in the system and cause the system not to pump correctly. And I get many calls, all of a sudden my system will not pump, and the reason why that happens is the first thing I have them check is, did somebody change the regulator pressure to something higher? And quite often the results are, yeah, we're running at 15 or 20 psi. I instruct them to set it back to 5 psi and the problem goes away. So make sure that you do not exceed 6 psi on the delivery side of your argon bottle, otherwise you might experience this problem. The system's coating, you can't see the plasma, but here on the display the film thickness monitor is recording a 4.2 nanometers of coating. It will terminate at 5 nanometers. It is sputtering at the normal rates, which gold sputter under these conditions. Okay, the correct film thickness was reached, 5 nanometers. Now the chamber is automatically venting to atmosphere. Once it goes completely to atmosphere and vents, and I can open the lid. Then I will switch to a carbon source to check the carbon supply, and we'll pick it up right there. Here you can see 5 nanometers of gold we coated on this cover slip. Looks perfectly okay to me. It's just become gold and not green, which is about the right thickness for your typical coating for scanning electron microscopy. Okay, I've installed the carbon rod insert in this 150R system. I'm not a big fan about evaporating carbon at low vacuum. Right now it's at 2 to the minus 2. You really need 2 times 10 to the minus 4 or better, ideally 10 to the minus 6 to evaporate carbon rods, but we offer it, so we're going to test this anyway with carbon rod, just to make sure that everything is working. So right now the source is outgassing. Yes, I can see the light. The pressure is rising. Now it is coating. The coating's done. It is now venting the chamber. As soon as it vents, we'll have a look at the glass slide and check out the carbon coating. Okay, as you can see, we have a very nice carbon coating on this cover slip. So we've fully tested the carbon evaporation process as well as the sputtering process for this tool that I just replaced the power supply in. So now it's time to put it back together. Now that I've successfully tested this unit and its replacement power supply, I will put it back to its original condition, installing the sputter head, getting that locked down into place. For reinstallation of the cover, we're going to make one modification. There's some foam insulation that we'll put around the back of the vertical piece, so the chances of any carbon flake or gold flake or whatever your material is you're working with sifts down inside the machine, potentially causing problems. We're going to mitigate this by installing the foam blockage for the vertical arm assembly. As you see, I've already detached my application lab, service labs display. So what I'm going to do is leave the display cable up here where it's easy to get to, because if you forget and you leave it down here and you have the cover on it, it's virtually impossible to fish it out. So the next step would be to disconnect the vacuum line, the electrical connections for the mains and the rotary pump, and the gas sources. So that's what I'll do next. Okay, I fitted the foam block and a new rubber shield to prevent any debris from going down into this hollow column and ending up inside the instrument. It's now time to remount the cover. This goes on exactly the way it came off. First thing I'm going to do is reconnect the fan while I have it balanced on the front of the system. It's helpful to, of course, have somebody to help, but most of the time I do this all by myself. So we got everything fit. It fits tightly around the case. All the holes more or less line up. So we will start to put it all back together. First thing we'll do is put the shoulder screw in. The shoulder screw just allows the arm to be raised and locked in the upper position. There's two different size chambers that come with this. The 6-inch tall, which is the standard one that you see here, and then one that's 12 inches tall to get your sources further away from your substrates. So now that that's done, I will slam the head down onto the bell jar, which of course I never like to have happen, but in this case it did. No harm, no foul. It's just that it's generally not really a good thing to do. Now I'm going to put the screws back in the sides of the tool case. And again, I don't use a lot of force. I just make sure that they're snug, and you never want to over tighten them. The next thing we'll do is we'll turn the instrument around. And I will reconnect the display to the power supply. Let's tighten it into place so it doesn't wiggle out. Plug in the internet connector. And now I'll put the back panel on. Once again, I just get the screws sort of started so we can get all the corners and such all lined up. I think I got all those. Now, learning from experience, I have put the back panel on, and on occasion have forgotten to attach the display, which means that you have to go back inside and fix that. But I don't think that's the case this time, but we will power the system once again just to make sure that everything is working as intended. Slide this down a little bit. I'll reattach the argon line. Turn the argon back on. I see the customer has a profile in place called Sputter Test 1. So I will run that profile and make sure that it goes through the proper sequence. It's bleeding gas into the system now. It's requested 20 milliamps of sputtering current. It's achieved that. I do have a plasma, so it is indeed working correctly. No use wasting the customer's target. Has version 63 software, which was the latest version, so the software doesn't need to be upgraded. So what I will do now is I will vent the chamber and then power it down and prepare it for shipping back to the customer. And that concludes this maintenance video on how to change a power supply in a Q150 series coating system. This is not the Q150 Plus series system. The case is a little different. It's mostly the same, but there are some differences. We'll do another video on the current series when time permits. So it's already vented, so I will stop the venting process, power the system down, and get it ready to go.